and then, okay, functional array methods. All right, so let's first talk about what I mean by method. And in this case, I'm specifically talking about instance methods. So a method is a function that acts on a class instance. So a class is something like an array or an object. You can also make your own classes, but for now, we're just going to think about the array class. And array instances, if you make an instance of an array, for example, by saying, oh, that's no good. For example, by saying, nums equals new array. So that's making a new array. Now nums has a bunch of methods. It's got properties that are functions, right? And the important thing is it has access to instances properties. So if the array, for example, if we look at the pop method, okay, I'm gonna have to get used to this interface. The pop method, it knows what the last element of the array is, and it will remove it and return it to you. And so it's important that these methods be able to access what's going on inside the array. And so they may return something.
Yeah, well, it is.
Or they also might mutate the instance. So, for example, myArray.fill replaces all of the array elements with whatever you put in there, and that actually changes the array.
Depends on where you're coming in from, right?
So, so let's go back here. I'm gonna make nums a new array that has 10 things in it. That's how you make a new array with 10 elements. And I have 10 empty items. So if I looked at the first item, what do you think I'm gonna get?
That's small.
Oh.
Undefined. Okay, but now if I do nums.fill with whatever, now nums has changed. First of all, that returned all of my whatevers, and nums itself now is different. It changed the array.
So it doesn't modify the original array, or does it probably
both. It modifies the original array and returns a new array. That's what fill happens to do. Different methods do different things. Okay. Cool. So questions on like method and what a method is.
Also a lot of finance and like understanding how
a method is a kind of function that is a property of an object. So, and the way you kind of identify them is that methods will be object dot, and then you call it. But yeah, method is a subset of functions. There are functions that aren't methods.
Why?
But all methods are functions.
You want to understand blockchain, you want to understand all the things that all the
okay.
Blockchain.
Cool.
Programming, but like methods aren't serialized. Economics, right?
You would just be.
What do you mean by serializable? Like if you like make
you to do smart contracts, testing for smart contracts, security.
Exactly. So see how you're talking about.
I don't think a method is valid JSON. Like for JSON, your values have to be like strings or numbers or arrays or other objects.
Well, I guess it doesn't.
All right, I just want to talk a little bit about functional programming. Functional programming is a kind of
that like no one knows
programming methodology where you don't, where everything is self-contained.
Working on my
so the one thing about functional programming is that you want to have pure functions, and that means you're like anytime you give this function. What am I hearing?
They're using like a lot of people using Mocha Chai. And I was like, holy shit, I'm trying to learn it right now.
Huh, okay. I'm finding it a little distracting. So pure functions, so if I give it some input now, and I get a particular output, at any time in the running of the program, if I give it the same input, I should get the same output. So if that means that the function should not have any side effects, it shouldn't change anything. It should, and like it shouldn't change any global variables. And also, it shouldn't rely on any shared state. It shouldn't rely on things being a certain way outside of the function. This is pure functional programming. Also, and this sort of follows that if you chain functions, the order should not matter. You should get the same result if you do a map then filter versus if you do a filter then map. Okay.
Yeah, but I'm thinking like it wouldn't be.
I don't even see volume on here.
Not enough.
I'm gonna stop. Is it playing something? Yeah, that's a good question. Let me maybe I do. Let's mute. Okay. I don't know. Maybe that did do it. It's coming from inside the house. Okay. All right. So again, you want to avoid any shared state, anything that functions share. So any global variable, or even a file, or a database. Like those really are. If you're doing pure functional programming, those are shared state between functions. You want to avoid mutating state. So if you're going to change variables at all, it should only be within a function. And then avoid side effects, things that are going to change something that is outside of the function. And if they're necessary, so if you do need to write to a database or save things to a file, really isolate that into its own function, which is better for testing and so forth anyway, right? So if you're going to have anything that's going to break these rules, keep it as contained as possible so that almost everything follows these rules. This is if you're trying to do functional programming. There are functional programming languages where you basically can't do things like this. Haskell is one, Lisp is an early one. JavaScript is not a functional programming language, but it does have some functional programming aspects. And so the array methods that follow this functional dynamic, there are a lot of them, but these functional array methods that I want to talk about, they take a function as an argument. So all of these take a function as an argument, maybe something else too, but at least a function as an argument. And then they apply that function to each item in the array. So you can think of these as iterating through the array as well. Yeah.
Why are those notated with pound signs and not dots?
Yeah, that's a great question. So the pound sign indicates that it is an instance method, right? So we know, and this, I'm going to show my my JavaScript ignorance a little bit. So we know that you can do like object. I don't know anything you can do with array this way. That's why I'm saying ignorance. But you can do object.keys of an object, right? And so this would be notated as object.keys. But if you're actually doing something with an object, and I want to do my obj.something, and I'm not thinking of any methods on objects right now. What's a toString? Great. That would be notated. That's not a very satisfying string of that object, is it? So object, if we were looking at just talking about it, this one would be notated as object.keys. And this one would be notated as object # toString, because that one, you actually use an instance before the method, as opposed to this one where you use the class itself before the method. That's something I didn't know before I wrote this lecture. Okay. For each. All right, so for each, I've linked, I'll make these slides available, and I've linked to the MDN documentation for all of these because the MDN documentation is really good. It's, it gives you examples, which I think are a great way to learn, and then it gives you a very formal definition. And then it tells you, okay, so it clarifies. So you're going to be giving for each a function. You give it an array instance beforehand. You're going to be giving for each a function. There is a current value, which is the value of the current element being processed. And then there is the index of the element being processed. And you also get access to the array. So we're not going to be working with anything today where we're going to be using the index in the array. But if you wanted to, say, be looking at the next item at the same time you're looking at the current item, then you might want to know what the index is and what the array is so that you can just look at array index plus 1. Does that make sense? So for example, let's look at a for each. So okay, and so now I can do a for each here. I can do a nums.forEach, and I need to give it a function. And so for the function, I'm going to say num, which is the current value, and then I'm going to say index, which is whatever index I happen to be on, and then I'm going to say array. So now, inside here, it's going to run this function once for every item in the array. And I can console log this num, whatever num I'm on, and then how am I going to get to the next num from here? So I just type index plus 1, like that. Well, but what if I didn't know what my numbers looked like? What if I didn't know that they were all sequential? What I want is I want to access the next item in the array. Does that make sense? So this is, so this is the array, which is just nums, because that's how for each works. And I know that I'm currently on a certain index. And so if I want to know what the next one is, I can just bump that index up by 1. You guys have questions on that? I don't know. I just don't know. Okay. Let's see. Oh, so now I have to close. Oh man, where am I? I didn't close this parenthesis. That's the problem of running stuff in the REPL, because now I'm screwed. So let's just take this and do it in Atom. Okay. Okay, and then I have to close that parenthesis, and then I have to close the function, and then I have to close the for each. Okay, so let's try this again. Oh, except, let's just get out of here. Okay, so first this num is 1 and the next num is 2. Then it's 2 and 3, then it's 3 and 4, and then it's 4 and undefined. We can make this a little bit. Let's do nums equals Now they're not numbers, but at least it might be a little easier to see what's going on. Okay, so first we're looking at A, then B, then we're looking at B, then D, then we're looking at D, then X, and we're looking at X, and why is this one undefined? What's the index? Yeah, the index is gonna be 5 at that point. Sorry, 4, because the index for this one is 3. And there is nothing at index 4. All right, cool. So for each, we're just running something for every item in the array. And the for each that I have here, I don't know how to make this full screen. I'm gonna have to figure this out. So the for each that I have here is just console logging every element. Notice that you don't have to put that index in array if you're not using it. Okay, so let's use another for each. Let's create an array of names given an array of objects, each with a name key. So let's get our array of objects, each with a name key. So let's say people equals, it's going to be an array of objects. And then I'll make another one. And then I'll make a third one. Okay, so I have an array of objects here. And if I want to make a new array using for each that has only the name of each person, how can I do that? So I'm going to do people for each. And what arguments am I going to use here? Do I need the index and the array, or am I okay with just the element? I actually think I'm okay with just the element, because here, if I say person, person is going to be, the first time through, it's going to be this object. The second time through, it's going to be this object. The third time through, it's going to be this object. Okay, so we'll say for each person. And then, well, I need a new array to add things to. So let me get rid of this for a minute, and I'll just say names, and I'll make that a new array. I could have also said names equals empty square brackets, would have achieved the same thing. Okay.
Is there one that you prefer?
If I'm just making an empty array, I would do the square brackets. Oh man, okay. So now I can do people.forEach person. And so once I have that person, what do I want to do with it? Yeah, so I want to get the name property and add it to my names array. How do I add something to an array? Push. And what am I going to add? You guys good with that? Okay, so I'm closing the function. I'm closing the for each. And now if I look at names, it has everything I wanted in there. All right, cool. All right, so that's for each. Let's move on to map. Now, map is if you want to make a new array, which actually is exactly what we were doing here. So you'll see that map could have done this a little bit more simply. Map is if you want to make a new array that has that's some sort of adjustment to each element of the array that you give. So my example here is I'm going to take every element. So if it takes a function in the same way the other one takes a function. I'm going to take every element in the function and I am going to return wow plus that element. And whatever I return is what's actually going to get added to my new array. And then the new array gets assembled. This function, again, this function gets run once for every element. It takes that, whatever you returned, and pushes it to the new array. And then at the end, that new array that it was sort of keeping in memory, it will, the dot map will return. So in this case, it'll get assigned to wow. All right, so let's do a my array is A, B, C. And if I do, now if I, oh, but I can't copy and paste that. Well, that's a real bummer. Okay, so dot map, I'm gonna take the element, I can call it word, and I'm gonna return word plus wow. Now, this, when I use my fat arrow notation, it'll just return whatever I give it after the fat arrow. If I was fat arrow notation with no curly braces. If I was using curly braces, if I was doing a multi-line, I would have to explicitly return this. Okay. All right, let's take an array of numbers. Do I still have, no, that is no longer an array of numbers. Okay, and if I want to get a new array with each of these numbers multiplied by 2, I can use map. So I'll say, okay, the argument is going to be a function. And what do I want to return here? Num times 2. So it's going to go through every element. It's going to multiply it by 2. It's going to add it to our temporary array. And then at the end, it's going to return that array, and which is going to get bound to mult by 2. Let's go back to our people. And let's write the same thing that we did with forEach, but let's do it with the map instead to get the names. So if I say names, I hope names isn't a constant, I'm not sure. So fine, I'm going to say now I'm going to I'm just gonna, can I also do del names? No, apparently that's a Python thing. Okay. So now, all right, so now I don't have anything, names doesn't really exist, but I do have people. So I'm gonna start with names equals people.map. And what's my function gonna be? Questions on this? All right, let's go to the next one, which is filter. So filter also takes a function, but this time the function is different. You want the function to return something, but this function needs to return a Boolean. This function is testing every element in the array. If it returns true, then we're going to add that element to our temporary array. If it returns false, then we will not add that element to the temporary array. And then at the end, it'll return the temporary array with all of those elements that passed the test added. Now this one, L mod 2, what data type is L mod 2? What data type does mod return? An integer, but I just told you it needed to return a Boolean. Yeah, I'm using a shortcut here. It's going to interpret whatever I return. It's going to interpret it as a Boolean. 1, you might have heard truthy and falsy. 1 is truthy. So if L mod 2 is 1, it's going to interpret that as true, and it's going to keep that element. If L mod 2 is 0, 0 is falsy. It interprets that as false, and it discards the element. If it's even, it's not going to return it. If it's odd, it will. So I'm using the sort of truthy falsy trick here so that I'm not actually returning a Boolean. Okay, so let's just look at this one. Just do I have a nums? All right, so nums.filter, and I'm going to say whatever the num is, I'm going to return num mod 2. So now I get only the odds. Let's filter for strings longer than 5 characters. So I'll make okay. So I want to say longer than 5, words.filter. What am I going to do here? Word. Well, it has to be a function, so I have to do a fat arrow. Greater than 5. So now I actually am returning a Boolean, right? Word.length, it's either going to be greater than or less than 5. And so it will just only give me the words. The way filter works, it'll look at every word. If this is true, it will give me the word back in my temporary array, which it then returns. And if it's false, it won't. So this function gets run once for every item in the array. It sees whether it's true or false, or truthy or falsy, and acts accordingly. So longer than 5. I got my longer than 5 words. Yeah, Jeff. Yeah.
I see how you got the odd numbers.
If I wanted to get even numbers, what would I do? So how could I, if I do this, how could I get even numbers? Well, okay, if I did just num, what would that do? What would that return, truthy or falsy? It'll return truthy unless the num is 0. So that's going to give me everything but 0. Yeah, I could put an exclamation point in front of it. Yeah, so if num mod 2 is falsy, then return true, basically. Another thing you could do is you could say, I want to return if num mod 2 is 0. This is a Boolean.
That's the most explicit.
Yeah.
Because I'm still struggling with how you're tricking filter into not giving you a Boolean, or into not giving you a Boolean. Here, I understand.
Yeah, this, I mean, filter is going to interpret whatever the result is of this as a Boolean. And because I know that 1 is truthy and 0 is falsy, I'm just sort of taking advantage of that. But yeah. But yeah, that's more explicit. No, we mod if mod 2 is 0, then it is an even number, right? I could do odds. Okay. All right, let's look at reduce. So reduce, it accumulates and then returns a value. So so here, like a classic example of reduce is sum. And I have, so reduce, you have 2 arguments that it takes. The first one is the accumulator, and the second one is the value that you happen to be on. And then whatever it returns becomes the new accumulator. So if I go to nums and I do nums dot, so I do sum nums dot reduce, I'm going to say my accumulator and my num, and I'm just going to return accumulate. Why did I write that? Okay. And so my sum, it added them all up. So what it did was it went through, and the first time it went through, the accumulator was 0 because I didn't initialize it as anything. I could explicitly initialize it as something. We can talk about that in a minute. The accumulator was 0, and the num, the first time through, was 2. So that returned 0 plus 2, and now 2 is the new accumulator. So then the next time, the accumulator is 2, and the num is 135. So that returned 137, which became the new accumulator. Does that make sense? So let's take a string, make a string that contains the first letters of each word in an array using reduce. So I'm going to make an array that doesn't have words that all start with the same letter. So okay, and so now I'm going to do words dot reduce. Okay, so what is this function argument? What is its arguments going to be? Accumulator and word. And what's it going to return?
First letter of word. So, you know, that's pseudocode,
But the problem is that we aren't taking into account what we've already accumulated. This is just going to give us the last word, the first letter of the last word, because we notice up here we did take into account what the accumulator was before, but here we're not using the accumulator at all. So basically it's just disregarding everything that came before, and first it's going to return A, then it'll return B, then it'll return C, then it'll return D, and because it gives you the last thing that it returned, D is all you're going to get. We can actually like just look at that. Yeah, just D. We forgot to add the accumulator. So we want to concatenate the accumulator and the first letter. What? It took the whole word. Why did it do that?
Oh, because the first word is after.
Yeah, the first word is after your accumulator.
The accumulator is bracket 0.
Well, yeah, maybe I ought to specify what I want my accumulator to start as. Maybe if I didn't specify that I wanted it to start as an empty string, it starts as the first thing, and maybe 165 actually isn't even the sum of these. That's all right. Okay, so the moral of the story is always specify what your accumulator needs to start as. Otherwise, it might give you weird things. And that's just the second argument. The first argument is the function. The second argument is initializing your accumulator.
The sum is 160.
All right, so I guess it just works differently for strings and
I
numbers.
think maybe it still took the first number.
With
as
numbers, it defaults to 0.
Does it?
Accumulator,
Okay.
So you get saved.
Why for strings wouldn't it default to? But okay,
String.
whatever. So yeah, okay. So now we've got a good reduce there. Cool. Other questions on that? Yeah.
So what are some use cases for reduce instead of adding
Well, yeah, usually you'd want to take things and make something other than an array out of them, right? So often it really is just adding up a bunch of values, but I don't know. I'm new to JavaScript. Ask me in a year.
I used it to,
Yeah, please.
One of the useful cases is unnesting nested arrays, I think.
Unnesting nested arrays. Cool. And sometimes we call that flattening an array. Yeah. Yeah, Jeff, and then Jedi. Cool. Awesome. And Jedi, what?
say for contacting, I use it to get the largest of set of like email addresses and names.
The largest set. What do you?
Like you have a list of names. You can get the one with the longest length.
Oh, the longest. Oh, right. So you would have some sort of logic here. You would say if the. Yeah. Okay. Yeah. Yeah.
A whiteboard interview when they were asked to take remove the duplicates from an array and and the use of objects. So where that string is second, or as a argument, they actually have some objects in there and run some logic, saying a default number is 0 for each of these, when it's an object. And if you find this again, add 1 to that object. And objects have
Oh, they have constant lookup time. Yeah. Well, so definitely. Yeah. Cool. Yeah. We'll talk about runtime some other time, but yeah, thank you very much for the examples. One of these days I'll actually do 3, 2, 1 contacts and maybe I'll understand. Okay. All right. You can also chain them. So here we want to chain the filter and the map to process an array of objects. So here I have pets. I have 2 cats and a turtle. And I want the names of only the cats. And I'm going to escape because I really want to copy this and not, oh, no, thank you. I know what all these words mean. So great. So now I have my pets. And so I want the names of only the cats. So I'm going to say pets. And how am I going to get the names of only the cats? Can do filter. So I can do pets.filter. And then I'll just say pet. And what do I want to return? Species, because so filter, you need to have a function that returns a Boolean that's going to determine whether it's going to be in your final array. So now I've got this dot filter, but that's going to return these 2 objects, right? And I can actually see that. It'll return the 2 objects that are cats. So now I want to chain. What do I want to chain onto it? Yeah, a dot map. If I chain a dot map, now I can say, now I can take just the name. Cisco is my cat. She really is 18. I do not have a turtle named Bruiser. All right. Cool. So, and true to functional programming, we should be able to reverse the order of that chaining. And it should give us the same result. Oh, actually, why doesn't it?
Because you're not getting species.
Yeah, when the thing that comes out of pet.name does not actually have a species. So not pure functional programming here. All right, so chaining. Jeff this morning came to me with an interesting question. So now, here is an array of arrays. We could use Breeze Reduce to flatten this if we wanted to, and maybe we'll do that if we have time. But right now, I want to create an array containing the largest number in each of these subarrays. So think about that for a minute, about how I'm actually going to do that. The largest number. Yeah, so I've got an array of arrays, and I want to create a new array that has the largest number in each of the subarrays. So right now, that would be 6, this number, and this number. So let's just brainstorm a little bit. How might I do that? Wait, hold on, Mira.
Or like strip the arrays, which is in the spread operator, and then iterate. Put in largest to get the largest.
Yeah, getting the largest one is part of the
From
key.
each array though, right?
Yeah, you have to get the largest one from each array.
I would do like you said, to reduce, get a flattened array. I probably, it's probably a lot of space. I probably assign a variable. Like if this next one is greater than that one, and return that variable at the end of that loop.
Okay, so we could loop for each array, loop through and determine the largest one and push it into a new array. So that would be using which of the functions that we've talked about?
Either map or forEach.
We could do a map or a forEach. Okay. So let's all right. Oh, not pets. Wait, hold on. Why does it do this to you? I feel like sometimes it just doesn't copy when I ask it to copy. All right. So so here we have this, and so we could do num array ours. And if we did a dot map, okay, what is the argument or arguments to our function going to be here? For the function that we're feeding to map. Yeah, we can just say array or num array. And then what do we want to return here? And that's where maybe we're going to do something a little bit more complicated here. We want the largest number in the array. Yeah, we can sort. We can definitely sort. You know, Python has a max function. Does JavaScript?
Yeah,
But it's, I know you do, I think, call binder apply is going to do app.x, but you have some special. Oh. Does it spread operator?
Math.max. Yeah, so let's, okay, so what do you think? Oh man,
You have to do
Because it's a nested
qualifier
array, I
bind
think
or
it's
something.
trying to,
Because, yeah.
it's
Well-
trying to do math.max on the whole array as opposed to.
No, I'm giving it num array every time. So the first time through, it should be this unnested array. The second time, it should be this unnested array. Let's just look.
You have to put some spread operators on the num array. You need each element of it.
Oh, I see. I see what you're saying. So, or you have to do an apply. All right.
Break it out of the nested arrays.
Well, it's not a nested array. It's just that it's an array and it's expecting a list of numbers, expecting a bunch of numbers as arguments. Not here, I'm giving it one argument that's an array, and it's like, yeah, of the arguments you gave me, not a number is the largest number because it's an array. You know, that's all I got. Whereas what it really wants is it without the array. So it looks like our two options are to do an apply with null or spread. I actually don't know spread. So,
3 dots. That's enough. And then wrap that.
That's new.
okay. So wait, tell me where do I put the 3 dots?
Could be math.max dot number.
Uh, Like that?
Yeah. That should be- yeah.
Okay. So dot 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 takes the array and makes it into a bunch of separate arguments.
And
Who knew?
takes
Okay.
multiple arguments and strips all the arrays and
Yeah.
makes copies so that it's immutable as well. To make copies of it.
All right, so let's try it again. So now we're going to say return math.max dot 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 num r. All right, cool.
Wow, I killed what we were doing.
Spread over is so
Used a
handy.
lot.
I mean, it's short enough too that you would need to use that new line.
Yeah, true. If you really wanted to, I could do.
And it serves another purpose too. It's a function that takes multiple arguments and makes a spread operator.
That's not my solutions.
Keeps feeding the function once it executes. I'm not sure if it's it.
Yeah. No, but that's exactly what it's doing here, right? Because the math.max takes multiple arguments, right? Here it's taking a bunch of arguments. And so we're just taking this array and separating it into individual arguments to make math.max happy. Okay, so let's see.
It also would break all the arrays. If you were to put it-
It would break.
Yeah, if they would have put
So you're saying if you were to do math.max dot num arrays instead of passing it a math,
Oh,
it would
well,
break all the arrays off as well. But no, yeah, it won't work.
yeah.
yeah, it will only return the one highest.
Okay, cool. Why don't we, just because we have it, why don't we flatten this using reduce? Okay, so how are we going to do it?
Just flatten the array, like take all the arrays off.
Make it into one array that starts with 3, 6, 2, 6, 4, blah, 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 blah. So it's going to be one long array of numbers. You could. Let's do it without using the spread operator. What does reduce? So the function that we give to reduce, what does that take as arguments? An accumulator. So I'm going to call that flat array. And what else? Then whatever the element is here, which is going to be a num array. And what do I want to return here? How can I take flat array and num array and sort of make them into one array. Yeah. Like this. Concat is an instance method, an array instance method. It doesn't take a function though, it just takes another array. Okay, and then, all right, so now I've got my function, but I also want to make sure that I tell it that I want to start my accumulator as an empty array, because I can get into trouble if I don't give it what my accumulator is first. So you're saying if I did num,
Although you'd have to wrap it probably.
nah, the REPL doesn't like it.
Maybe it's like dot 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 and then num arrays in parens, like just num rs in parens. Try that maybe.
Yeah.
In every other instance, doing something, like it's being used as an argument. Yeah, so I think it could be used as an argument for a concept about log, for instance.
No. Look at you, but it doesn't. It actually, yeah, it doesn't like super flatten it. So Breeze.
Is it one of those things that doesn't change the original array? I think it just manipulates it.
Right, definitely. I think you would have to do like a map or yeah. Okay, and just at the end, I'm gonna make this available to you. So at the end, I have some resources. If you want some practice with map and filter and reduce, and it also uses concat all and zip, there's a place you can practice. There's something that that tries to rewrite map, filter, and reduce, which I think is a very Trevor thing to do. Like I think he likes to like understand the inner workings by rewriting things. And then just if you want to learn more about functional programming, I have a link there too. I'll post this in phase 1 and phase 2, as well as the video recording. But that's going to have to wait until after lunch because I'm meeting a friend for lunch and she's been texting me. So, okay. All right, cool. Thanks, guys.